Assalamualaikum warahmatullahi wabarakatuh and good morning. I wish to my respected lecturer Encik Wan Afnizam bin Wan Muhammad, our lecturer for BFC 21103 Hydraulic for this semester. We are from Group 6, Section 1. We'll present about our group project, which is Capacity of Open Drain and Swale. Before we start to more detail, I would like to introduce myself and my team member. Me is Sofia Adrina binti MB Jamil. My mentor number is CF240244. And we have Nordamia binti Mono, CF240115. And next we have Nafisah Muasri, CF240104. But last but not least, we have Fazli binti Nik Husin, CF240081. And the last one we have Zari Iskandar bin Muhammad Hafizan, CF240195.
Assalamualaikum warahmatullahi wabarakatuh. My name is Fazli binti Husin. My match number is CF240081. So I will continue to present about introduction. In hydro engineering, managing stormwater helps prevent flood, erosion and damage to infrastructure. Two common systems are open drains and swales. Open drains often use concrete to control flow, while wells are greasy and eco-friendly, slowly and absorbing water. This study case their effectiveness using factors like shape, roughness, and flow rate, guided by the Manning equation to ensure safe and suitable drainage. That's all. Thank you. I will pass to the next presenter.
Thank you to Nora Fazlin. Next, me, Sofia Adrina, CF240244, and I will continue for drainage. As we know, the efficient design and analysis of surface water drainage systems, such as open drain and swale, are essential to mitigate flooding and erosion risks within a campus environment. This study focused on evaluating the hydraulic capacity of selected open channel system within the University Tun Hussein Onn Malaysia, particularly examining their ability to manage peak runoff during the intense rainfall. Next is definition of drainage. A drainage study is a fundamental aspect of hydraulic engineering that focuses on management and analysis of surface water flow within a specific region. As we know, at University Tun Hussein Onn Malaysia, UTHM, drainage systems are extremely critical due to increasing construction activities around the campus, which may dramatically change natural water flow pattern and cause possible concerns such as flood, erosion, and structural damage. So that's all for drainage system. Thank you. Next, I will continue for objective for this project. The first one is to calculate the hydraulic capacity of an open drain and a vegetated swale. Next is to compare actual capacity with the expected stormwater runoff. And the last one is to identify whether the current system is adequate or need to improve. So that's all from me, and I will pass to the next presenter. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Zari Iskandar bin Muhammad Hafizan. My matrix number CF240195. Today I will present about my part, problem statement. The drainage system at University Tun Hussein Onn Malaysia plays an important part in controlling rainwater flow, especially during time of heavy rains. Open drains and swale are widely used across the campus. However, their hydraulic capacity under full flow circumstance has not been fully examined. A lack of information regarding the real capacity of these drains can lead to system problems, including overflow, limit flow, and possible damage to infrastructure. To correctly assess drain performance, important factors such as drain size, slope, flow velocity, and roughness coefficient must be considered. Therefore, this study aims to measure the capacity of chosen drains across the UTHM campus by performance hydraulic analysis to ensure the present system can handle the planned flow rates. The results will show possible for improvement and suggest a minimum freeboard 50 mm to ensure the system safe and operating efficiency. So that's for problem statement. So I will go to the next part. So despite I will present about site of study area. So the location of the project is in part of University Tun Hussein on Malaysia area. First place at FKMP G2 Lab Complex Perimeter, and another one place need to present at C15 next to Arcade Perimeter. For this slide is proof that we went to the site to take data. For the second picture from the right, picture in FKMP lab, and the rest in C15. Okay, that's all for me. I will pass this presentation for the next presenter. Thank you.
Assalamualaikum, my name is Nurdamia binti Muhammad Noor. My matrix number is CF240115. So my part, which is for methodology, I will be representing about how to measure of this channel. First, we need a tape measurement for measure the dimension of the image. Next, we need pen and sheet for take a note during the site recognitions. Furthermore, for the next methodology that we have in here, they have a three shape that we need to find if we're using a different shapes, which is we have a rectangular, trapezoidal and circle. This is the formula that we need to find when we in the area or top width and water parameter in a different shape. Which is in here, we need to find a radius and also a velocity of flow and capacity of drain. In our project, we use a rectangular shape in the drainage system, which is we need to find a parameter and equations, which is it have given a cross-sectional area, weighted parameter, hydraulic radius, and a discharge. In discharge, we need to find determine using a Manning's equation. We need to find where it have given for the flow rate, and then for the flow area and the hydraulic radius.
Saya Nur Nafisa Muhammad Asri akan menyambung pembentangan tersebut dengan menunjukkan calculation di location yang pertama. Location yang pertama ialah CF15, merupakan next to arcade, di mana drainage tersebut type of lining dia ialah precast reinforced concrete, bending roughness dia ialah 0.015 dan SO dia ialah 0.002. Dan berikut ialah dimension of drain, and untuk mencari weighted perimeter, formula dia ialah P plus B tambah 2Y punca kuasa 1 plus Z kuasa 2. Untuk mendapatkan Z, kita menggunakan formula T tolak B per 2 darab D. Dan dah dapat Z, baru masukkan formula di dalam weighted perimeter. Dan berikut ialah nilai untuk weighted perimeter. Next, kita boleh cari area of flow. Area of flow A equals to BY plus ZY kuasa 2. Dan area dia ialah 0.0353 meter kuasa 2. Dan kita boleh cari T. Kemudian, kita boleh cari untuk R pula. R, formula dia ialah R sama dengan A per P. So, nilai untuk area tadi bahagi dengan weighted perimeter dapat 0.0695 meter. Seterusnya, untuk mencari capacity of drain, di mana ialah Q, formula dia ialah 1 per N darab A darab R kuasa 2 per 3 dan darab SO 1 per 2. Dan mendapat 0.0563. Untuk mencari velocity pula, V sama dengan Q per A. Q kita dah dapat tadi dan area juga kita telah cari. Dan velocity untuk drainage location pertama ialah 1.595. Saya akan sambung dengan location yang kedua ialah FKMP. Type of lightning drainage dia merupakan grasswell, short grass. So, bila kita tahu dia grasswell, short grass, Manning roughness coefficient dia ialah 0.03 hingga 0.035. Dan SO dia merupakan 0.008. Dan berikut ialah dimension of drain. First sekali, kita kena cari weighted perimeter, iaitu P sama dengan B tambah 2Y punca kuasa 1 tambah Z kuasa 2. Untuk dapat Z, kita guna formula T tolak B per 2 darab D. Dan bila kita dah dapat Z, kita boleh masukkan dalam nilai weighted perimeter kita dan mendapati 3.26 meter. Next, sambung dengan area of flow. Area of flow, masukkan nilai area trapezium dan masukkan seperti biasa. Kemudian, untuk menggunakan R pula, untuk dimasuk ke dalam formula capacity of drain, di mana Q sama dengan 1 per N, A R kuasa 2 per 3, SO kuasa 1 per 2. Kita akan cari R dulu. R ialah sama dengan A per P. So, A ialah area yang telah kita cari tadi. P ialah weighted perimeter yang awal kita cari tadi. So, kita dapat R sama dengan 0.28. Baru boleh masuk dalam formula Q. Q sama dengan 4.421 meter kuasa 3 per second. Next, untuk volume pula, formula dia ialah V sama dengan Q per A. Dapatlah volume kita 4.785 meter per second.
For the conclusion is, the study focused on analyzing the hydraulic capacity of two types of open drainage systems situated within the University Tun Hussein Omnishu campus, a greases swell at the FKMP G2 lab complex and a precast concrete drain near block C15. The study involved 12 hydraulic formulas to determine the efficiency each drain in moving rainwater runoff, especially under full flow circumstances. Key factors such as the Manning's roughness coefficient, which is N, the flow area, velocity, and discharge capacity, which is Q, were considered in the study. That's all from us. Thank you.